Hello, this is Braden Cooper here with One Stop Systems, here today to talk to you about the 3U short depth server, our 3U SDS. This is a semi-rugged server designed to go into vehicles, whether that's autonomous vehicles, military applications, a wide variety of semi-rugged environments. One of the main features of the 3U short depth server is these removable canisters in the front. Say in your vehicle application, you're capturing AI data with all your sensors, all your camera feeds, storing it onto these canisters, and when you end your mission you want to take those off. You can simply, while the system's even running, pull the canister out, and you have now up to eight NVMe SSDs that can be securely put it in a briefcase under lock and key, carried over to your data center, your ground station, inserted into a corresponding short depth server for very high speed and secure data transfer. And here we're taking a look at the rear of the 3U short depth server. A couple things to highlight here. First of all, it has dual redundant CRPS power supplies. We can support up to 2600 watts in each of these power supplies, which should be more than enough for any of your applications, making it typically an N+1 redundant configuration. These power supplies can also be easily removed and replaced with matching power supplies. You also see the motherboard I/O here. This is specific right now to our single socket AMD configuration of the SDS. We support multiple motherboards in this enclosure, which vary both the I/O panel and the number of add-in card slots that you see. To highlight a couple of the features on the motherboard I/O panel, we have, based on the motherboard you select to go into this configurable product, we have onboard LAN connections available. We also have up here access to our baseboard management system that One Stop designs and develops for this product. That'll give you access to temperature, fan, thermal, power, and other data through a IPMI-based web interface. We'll open the cover up and dive in and show you the add-in card slot configurations. All right, now we're going to take a look inside the 3U SDS. To remove the lid of the 3U SDS, you simply undo the fasteners along the top of the lid and then along both sides of the lid. Once you do that, you can pull it out and then lift up to remove the lid. One feature to highlight on the inside of the lid is this hold down bar that we have in place. This hold down bar is a part that can be modified to fit the specific add-in card slot configuration you have. And this allows the add-in cards to be securely held from the top and then from lateral movement as well to help mitigate some of those vibration and shock environments that the system might see. Okay, and then diving into some of the features inside of the 3U SDS. First thing you'll notice is this board right here. This is our system monitoring board. What you can do is put a optional module that we have that goes in here, an SODIMM module that contains the One Stop system monitoring software. That module that goes in here can read all of the sensor data throughout the system, including the fan speeds, the temperature data, the power controls, and you can power on the system, power off the system. Long list of features in that baseboard management control. The next board back here is our power distribution board, our power supply backplane. This is where the CRPS power supplies plug into, and from here it distributes the power to the rest of the system. You'll see there's a number of auxiliary connectors here to power your add-in cards that require auxiliary power, such as GPUs. The next feature you'll see back here is our drive canister backplane with a number of SFF8643 connectors along the back here. Those connectors dictate the drive configuration, whether it's SATA or NVMe, and how many drives you want to support, all of which are configurable options. Okay, and now we're going to take a look at the motherboard options that the 3U SDS product supports. The one that we have currently installed in the system is a PCI Express Gen 4 single socket AMD motherboard. This is ATX form factor. A couple features of this motherboard. First of all, it does support two PCI Express Gen 4 NVMe M.2 drives that can be installed on the system. It also has 7 PCI Express Gen 4 by 16 expansion slots, all single width, so that can be used for FPGAs, SSDs, really any add-in card that's single width can go in those slots. The second motherboard that we support is the ATX form factor dual AMD motherboard, which shares a lot of the same features as the single socket AMD. but it does go down to 6 PCI Express Gen 4 by 16 expansion slots, but it does have the benefit of being a dual processor, dual AMD motherboard. The third motherboard we support is an extended ATX form factor PCI Express Gen 4 with 6 PCI Express Gen 4 by 16 expansion slots and 1 PCI Express Gen 4 by 8 expansion slot. The benefit of this motherboard is, first of all, it's a dual Intel-based motherboard compared to the last two. In this one, the 4 of the PCI Express Gen 4 by 16 expansion slots are actually dual width, which is great for GPU-based applications or dual width expansion cards. You can connect auxiliary power over to those cards, get them sufficient power, and run them in this motherboard. Some of the features that go into the system to make it a semi-rugged platform. First of all, this is all an aluminum construction, meaning it's very lightweight. We've put bracing throughout. You can see along the bottom here, there's some folds in the sheet metal, as well as this strong crossbeam right here. Those are all designed in place to mitigate the low frequency resonance that you might experience in a vehicle application or any application where there might be some vibration that the system would experience. This bracing all mitigates that. The lightweight makes it less affected by such exposure. Speaking to the cooling, we have fans you can see throughout, both this large fan here, as well as fans behind the NVMe storage canisters, and there's also an additional row of fans underneath, which all provide optimal cooling to the CPUs, to the add-in cards, and to the storage drives within. The system is liquid cooling ready. We say that for if you have a GPU that you'd like to have liquid cooling support in, you can drop the GPU into any of the add-in card slots here and run the liquid cooling out the back of the system. Okay, what you see here is one of the bulk removable canisters. This is the semi-rugged variant of this bulk removable canister. Like I said previously, this supports up to 8 drives. It can support actually either SATA or NVMe, but you can fill this with 8 NVMe, which would be the highest performance that you can get out of this canister. Some of the features of this, first of all, it's again an aluminum construction, very lightweight canister. Highlighting some features on the back here. First of all, this is the one-stop systems drive backplane that we designed to support NVMe or SATA. One of the main benefits of designing it ourselves is we've optimized the airflow coming out of the back of here. You can see there's some wide open air slots here. That allows NVMe drives, which generate more heat, to be able to cool effectively in rugged, extended temperature environments. Additionally, we have guide pins along here that allows you to blind insert this canister. It can be hot swapped, so you can, while the system's running, blind insert it, and it will always insert properly due to the guide pins. Additionally, we've selected connectors here, which have very high insertion cycle counts. So this is designed really for daily or any frequency of removal and reinsertion of this canister in the SDS server. Speaking to other variants of this product, if you want the data center varietal, we call it, for the SDS, you can remove this front bracket here and this front handle. And then on the SDS, you can have 16 individually removable drives, just like you'd be more familiar with in a data center environment. Okay, and then talking about the mounting provisions for the 3U SDS. First of all, it can be rack mounted in a standard 19-inch rack. We do support toolless removable rack slides. Along here you can see the tabs where those would mount. It does have rack ears as well for mounting to your standard 19-inch rack. Additionally, we do support flange mounting on this product, meaning you can design a flange mount system to attach to the side of the 3U SDS to bolt the entire system down to whatever your environment may be, whether that's in a vehicle or other semi-rugged environment. It can use the same mounting holes that the rack slides use and then bolt it to whatever your application might be. Okay, and now to talk about some of the use cases that we've seen for the 3U SDS. First of all, in the autonomous trucking industry, we've seen the system deployed primarily as a storage server. What these autonomous trucks are doing is capturing their sensor data, whether it's LiDAR or live camera data, they'll feed it into the storage drive canisters up here. And then once they reach their depot or destination, they'll remove the canister, carry it out of the truck, and then place it into the ground station at the depot to offload the data and then upload it from there. Much quicker workflow than trying to go through 5G, much more secure. You can transport the data under lock and key, and it keeps the trucks on the road. You'll be able to reinsert another canister and resume your road trip immediately. Another application is in the military side. We've seen this deployed in mobile command centers, really as a GPU or even a hyperconverged AI workstation, where they're implementing or they're inserting up to 4 of the highest end PCI Express Gen 4 GPUs, such as the A100, along with FPGA capture cards to capture incoming sensor data. They'll process all that data on here and then offload it to the rest of the mobile command center for actionable mission intelligence. Now, the same canisters that are removed from the 3U short depth server can also be inserted into our Centauri product, which is a storage acceleration system, which can be connected to any server for mobile or external storage expansion. And now we'll take a deeper look at the IPMI baseboard management functionality of the short depth server.
The short depth server, or SDS, comes equipped with an IPMI 2.0 compliant baseboard management controller, or BMC, that monitors and controls the system.
There are 3 modes of accessing and utilizing the BMC, depending on the level of monitoring and control desired. First, there's a simple system, status, and information screen accessible via a web browser that provides health status in an easy-to-understand display. Second, there is a command line interface with a rich set of commands that provides both monitoring status and remote control of various parameters in the system. And third, there is a full-featured API for integration of the system into larger IPMI-compliant customized monitoring and control systems that you might have in your facility. For purposes of this training video, we will show examples of the health status display and command line interface. A programming guide is available with all the available commands, as well as instructions for implementing the API into custom systems. To access the BMC in the IPMI-equipped OSS system, connect the system to the management network via the marked BMC RJ45 connectors on the rear of the system. Once connected, you can search for the IPMI or MAC address of the BMC. The MAC address may be found on a sticker near the port on most OSS systems, or you can manually search for the IPMI and MAC using a tool such as Advanced IP Scanner shown here. After fully scanning the network for available IP and MAC addresses, you can search for the OSS BMC MAC address, which always starts with a 00:18. In this example, we find 2 OSS BMCs on the network. Since the OSS products can scale from 1 to hundreds of systems in various server expansion and composable infrastructure architectures, you may find more on your management network. In this case, we're interested in the BMC connected to the IP address ending in 146. So we copy this IP address and switch over to a web browser where we can paste this address into the search bar. This brings up the monitoring screen, which will show various live parameters, including system and component temperatures, fan speeds, and power supply voltages, which you can see update about every second. Your screen may be different depending on the system configuration, number of backplanes, power supplies, or fans in the system. In this case, there's 1 backplane installed with 2 temperature readings, one near the air inlet and one closer to the air exhaust of the system, so you can get an idea of the instantaneous temperature profile of the system. Now, for more advanced monitoring and control of system resources, such as setting the IPMI BMC security policy, adjusting fan speeds or automatic fan speed profiles, remote system reset or on-off functions, things like that, a command line interface is available. Since we know the IP address of the BMC, we can use a tool such as PuTTY, shown in the demo, to access the BMC command line. For first-time login, the security policy is not yet set, so you can enter the BMC using username root and simply hitting enter for the password. It is highly recommended that you consult the programming guide to set up the BMC security login and password according to your company's security policy. A list of popular commands is provided upon entering the CLI, and you can issue the ls command to see a larger list of available commands at this level of the directory. To control a parameter such as fan speeds, the command fan_adm1026 will provide instructions on how to set up your CLI command. For something like remotely turning the system on and off, the command pwr_adm1026 will provide a similar set of instructions for issuing power on and off commands. Since the BMC runs on standby power, as long as the OSS system is connected to a live power source, the BMC remains operational to provide status and accept commands through the CLI or browser. There are many more commands available, and please consult the guide. And for more advanced CLI or API implementations of the one-stop systems IPMI BMC, you can also consult the programming guide.